UOIT. Tell me about the problem you're tackling, then the process to solve it, the solution, conclusions, and limitations. Yes.
Right, so what I did, so the problem is that we have our current electrical grid infrastructure around North America or around the world is old and old and outdated. What we plan to do is to upgrade that power grid in order to manage the increasing energy demand and decreasing power generating plants around Canada. So for that solution, what we have created is a smart grid solution for UOIT campus. In order to make a change outside, we need to start from home base. That's why we have built a prototype of the UOIT model with an actual smart grid implemented. A smart grid has 5 main components. Renewable sources of energy, which this is a solar panel. We can wirelessly control our grid through this GUI system that we have over here.
Right.
As the GUI shows you the solar panels power generation, our loads consumption that we have here, and our smart meter that we have over there at the back. This is a typical smart meter connected to our system through this USB from this monitor. This monitor takes the value from the sensor, puts in the transmitter, and into the USB over here. So now, not only can you see your power consumption, your power generation, it's a bit sketchy right now. It doesn't work that well here because of the light here. So what we have right now is the GUI system that controls the grid and helps you monitor and manage the grid at the same time. So apart from that, we can also do fault analysis. It's a huge factor of fault analysis in any grid to have. We will create a fault right now in the grid system. Our prototype will isolate the main transmission line, take away the power from the main load, wait for a few seconds, and then send power through the alternate power supply back to the main load. So I just created a fault here, if you can put the video here.
Okay, good. So the fault has caused the power supply to go off.
And now we have provided the same power to an alternate power supply over here.
Okay.
So now we have not only did fault analysis, we have regained our power back from the fault. Also, not only can you monitor it, manage it, but you can also control your grid. For example,
so if there are any faults at our UOIT building, you can easily recover that.
It will automatically connect. I did nothing. All I did was create a fault.
Create a fault?
The system took care of it own self.
Good.
Now we have the power back to the lamp. I can also control my grid wirelessly. I shut that guy off and I can turn it back on.
Okay. You're controlling it wirelessly, okay. So but where is your, when you're controlling it, which hardware is receiving your signal?
What I've done is that we send signal through our remote system here.
Yes.
Into these wireless sockets.
Yes.
These wireless sockets are connected all through our model.
Yes.
And we have 6 loads on all these 6 sockets. That way we can control our loads wirelessly on the remote. And these guys, these transmitters are connected to our voltage and current sensors and smart meters to show you how much power consumption you're doing. So we have the energy reading, we have the control, we have the monitor, and we have our demo here.
Good.
So overall what we have achieved is we have made a smart grid system, a proposal for a smart grid system for UOIT, so that in the future UOIT can set an example for other universities around North America and around the world.
Smart grid is more of a general word. It means that there are certain features where you can digitize power, you can control the power.
Yes.
So you showed how you can easily control it wirelessly. So give me a real world example. Say I'm a administrative
Facility management.
power management person, and what can I do with the system? Say at a building that I have. Say I have the ACE building where it's consuming every day.
For example, there's a big fan, mechanical fan in ECE which uses 2 megawatts of power.
2 megawatts of power.
Right now it's peak time.
Yes.
If that fan is running for no reason, you're wasting 2 megawatts of power and you're paying that much money to make it running. What's the point of it?
But then couldn't someone just switch it off?
Exactly. Over there, you have to go to the east building to switch it off. Right now it's raining, there's a storm outside. Smart grid is to smartly manage your grid, sitting from your control room, and you need to have a remotely control your system. That's the key, the remote control.
Yes.
You should be able to sit in your control room and control the entire grid.
So you have a control room interface where you can visualize which load is consuming how much, and you can control it.
For example,
remotely.
if you want to go to ECE, you can't go there and switch the button off, because not everyone has the authority and the access to the control panel at ECE, because it's very proprietary and restricted information. So you don't have the information even if you have facility management. But if you have the control GUI system here, you can send an on and off signal to that fan from here and save your power and your money.
So give me a demo of the interface you have over here. What is it doing? What is it showing?
The GUI system is done by Wesley, and he will explain to you.
Right. So right now the GUI system has 3 graphs on it, as you can see. The top two, there's 2 graphs on top which has 30 points on them, and then there's the bottom graph which has 40 points. What it's doing right now, it's polling 1 point per second from the USB and graphing it. So as you can see, at the x-axis of each graph, it shows the exact time that it pulls the information on the local machine that the software is running on. So you can technically set it so that it pulls like every minute or something, but you can see that exactly what time the information is pulled.
Building A, it's a simulation data? Or
Yes, this is simulation data from these things.
Okay.
So there's simulation data on the transceivers right now, and then they're transmitting to the USB, which the GUI is grabbing the information and plotting it.
Got it. So this would be something a control room.
Yes.
This could evolve into a full-featured control room UI.
Yes, right.
There's a person dedicated to actually make sure all power is being controlled,
Yep.
no wastage is happening.
Exactly.
Okay, because at the moment, can a control room person remotely switch off equipment or no? No?
You have to go, for example, I worked at OPG, and you would have to go into the facility, go in the most hard to reach places and turn it off, because many of the power plants were created back in the 70s. They weren't exactly built for on and off all the time. That's the issue. We need to have remote control of our grid, so that at any given time, right now it's peak time, so you would have to go walk all the way through the grid system to turn one load off. That's not really acceptable in this society, because everything is wireless. We have smartphones, we have all the fancy toys now, so why not have a remote control of the grid?
Okay. What limitations does this project have at the moment? If you have more time, you'll improve upon the limitations.
The distance. These
Distance?
guys,
Okay.
the distance for these guys is
Yeah.
only a few meters. Maybe across the wall, you might not get that per second. You're getting real good values right now. It may be up to 5 seconds if you go through a wall, 5-6 walls.
Yeah.
In order to improve this, we can have antennas that can go over kilometers.
What is this again? Remind me. So this is receiving?
This is a transceiver. This is
Okay.
This is an example where you connect sensors over here in these
Yeah.
pins, and it'll send those sensing values into your USB, and you can simulate it over here.
Okay. So, like when I'm seeing data over here from my loads in my building,
Yes.
what instrument is sensing or sort of sampling the power?
That depends on you, what kind of load you have. For example, there's certain loads that, for example, will use relays, directional relays, or distance relays. It depends on where your load is or how far away the load is from your system right now. Also, it also depends on, for example, you can connect your smart meter here that we have, a typical smart meter, to our sensor here. This sensor can read power consumption values from your entire load as a building and send information here.
Okay.
So instead of every load in every building, you can have one building as a load and put it over here.
Perfect. Good. Awesome. All right. Thank you. Awesome project. So give me